Okay, let's look at some more examples here. Again, I'm not going to talk through all of them, but take a look at, we have these contingency tables, and so notice we have totals on columns and rows. And so of course you can pause and get the answers. I think the more complicated ones as we want to look at are going to be the and or ors as we get through these. And so you can see where I get the 260 out of 500. There's the total of being female and having a piercing. That's my PD symbol. 268 female and piercing is and. Student is a female and non-binary. Female and non-binary. Notice you can't have them. There is no intersection, right? And so that's what would be a 0 out of 50, according again to our contingency table as we look at it, right? Female, non-binary. You will see there's no overlap within it. Now things get a little bit more interesting on F. The student is a female or has an ear pierced, so it has a piercing, right? And so in this case, here's the female, right? There's 291. Piercing, you're here. And so there's 324, but we have to kind of sort out a little bit of this, right? There's this overlap between piercing and female. So you can see 291 are female, 324 are pierce, and then I end up subtracting out. I end up subtracting out the 268 because there's an overcount as we add these up. 291 plus 324, I have to subtract out one of the 268s because it was there twice. 268 plus 23 is 291. 36 plus 268 plus 20 is 324. Notice it was added twice, and I don't want to double count. And so you end up with that fraction right there. And then we get to a given situation. What is the probability that a student has a piercing given the student is a male, right? And so we're selecting a male at random here, right? Given that the student is male. And so we look, there's only 180 males, 36 out of 180. And then you could convert that to your decimal, right? But there's your fraction there. Probability of being pierced given that you're male. We're only selecting males, right? And so that's that language of given. And so we'll look at, again, another example of that. We'll get practice on these. Here's what we would do this in class, but again, looking at it, very similar. I'll let you play that out as you look at those again compared to what we had up above. You can see, and I'll look at this given one. Notice again on the D and E, I had to subtract out because there's some overlap within that context, right? Students are counted twice. Snapshot given you on an iPhone. So given you an iPhone, there are denominators 20. We're only selecting iPhones, people, and then 10 out of the 20 and so forth there. Continuing on with some more examples here, more rules on probability. There's another term we get to which is called disjoint, right? Events are disjoint if they cannot occur at the same time, or mutually exclusive is the other term. So some people choose one or the other. I always get confused. Mutually exclusive confuses me for whatever reason. But disjoint is a term that I can understand. They're not together, right? They're disjoint. They can't occur at the same time. Mutually exclusive. Mutual seems together, so I get confused. But exclusive is the key there, right? And so here are all examples that are disjoint and not disjoint. So if you can go through that a little bit. So I don't have to talk through that, but you can see again, disjoint events. They cannot occur at the same time. Some rules that come from disjoint, recognizing as we have these disjoint events in our world, right? Complements are always disjoint, right? You can't one or the other. Passing a test and not passing, you can't do it at the same time. If it's the same test, two events are disjoint, then the probability of A intersect B equals 0, right? Because it can't happen at the same time. Both of them have happening is 0. That's the probability. Now here are the official rules that we have for the union, the addition rule that we kind of intuitively calculated up here by subtracting out. Here are the rules again. If you have events that are disjoint, then you just add them up. If the events are not disjoint, then you have to follow this. And so then there's some overlap, intersection when they are occurring occurring at the same time. We have that, so they have to be subtracted out, which again happen over here on this problem here, and happen over here on this problem over here on F. So that's where we got you an intuitive idea, but now we give you these terms, disjoint, and then this formula for it. Example 9 shows you another situation here for this, right? And so you have some overlap, right? 9% of the owners hire someone to both maintain their yard and the home, and so that's where we have to subtract out that intersecting part. So you can see a Venn diagram. And then once you have that, the complement, right? This would be the complementary event here. Select an owner who neither hires someone to maintain their yard nor clean their home, right? That's going to be, because this is the or part, this is the complement, and so you have that there.